In the last video, we saw what makes an organic compound acidic in nature. Today we will see what factors increase the acidic character and which factors decrease the acidic character. 2 points must be noted. Number 1, factors which help in release of proton, that is proton loss, make the compound more acidic. Those which discourage make it less acidic. We will take the examples. Second point, the conjugate base that is formed, if it is more stabilized, that is, it is weaker. More stabilization, weaker, of lower energy, then the acid is stronger. And just the reverse, if is stronger the conjugate base, that is less stabilized, of more energy, then weaker is the acid. These 2 points must be kept in mind. We will take the first one now. We take the example of carboxylic acids. H has no effect, so we can compare other acids with this. If you put one CH3 here, this has a plus I effect, sends electron density away from it and creates a delta minus charge here. You know this from our earlier discussion. Now, if this compound has to lose proton, this will have to leave behind these 2 electrons. But there is already a small negative charge on this, and this will discourage taking the burden of this electron pair over it, and hence this compound, acetic acid, is a weaker acid than formic acid. pK values 3.75, it is 4.76. Put one more carbon in between, again there is inductive effect. It is stronger, you know, ethyl group has stronger plus I effect, and this delta plus minus will be somewhat higher and it will be less acidic, 4.87. Almost of the same magnitude is the effect of this group. This is nearly 4.86 pK value. Put 3 methyl groups here. They all push. A very strong delta minus here, and this compound has pK value 5.05, still weaker. So, these are the cases when the acidic strength decreases. If there is minus I effect here, then you will observe the reverse. This has minus I effect. This has a delta plus charge. This will encourage in accepting the burden of these two electron pair. So, proton is a bit easily lost because this loses this electron pair easily here, goes as H plus. So, this was 3.75, this is 2.85, stronger acid than formic acid. Put 2 chlorine atoms, both withdraw, and this has a value 1.25. And this has 0.66 pK, very strong acid as compared to this. I have written few cases here. Greater the I effect, more is the withdrawal, and the acid becomes stronger. 3 fluorine atoms, see, such a strong acid, only 0.23 pK value, NO2 1.68, 3 combined together is stronger than this NO2. Then CN minus I effect, all these have minus I effect, and the value of pKa goes on increasing, the acidic strength decreases because inductive effect of these groups is decreasing in this order. This is about inductive effect. Now, the second point, stabilization business. How does that help make compound acidic weaker or stronger? We want to see whether this is strong acid or phenol. We will see first their conjugate bases. If you write the structures, relating structures for these, you will find and so on. We want to compare whether this system is more stabilized or this system. Here they are of equal energy. Similar structures. Here you are finding that negative charge lies on oxygen atom in this structure. Here you find the electron pair or negative charge on a carbon atom, in this here a carbon atom, and so on. So, negative charge on a carbon atom is less stabilized than negative charge on an electronegative atom like oxygen. So, these are not of equal energy, these are less stabilized than these structures. So, there is a lesser stabilization of the conjugate base. Hence, acetic acid is a stronger acid than phenol. Benzoic acid is similarly a stronger acid than phenol because of the COOH. This has a value 9.98 and this 4.20. In the next lecture, we will see the effect of groups attached on the ring on the acidic strength of the acid, or in this case, if the groups are present here, what effect they will have on the acidic strength of phenol.